Hello again. The next lesson on the agenda is properties of addition. And the properties of addition are the commutative, the associative, the identity, and the inverse. And when students first learn this, they kind of groan and moan a little bit, oh, this is so terrible. It's not really terrible. I suppose memorizing the names can be a little difficult, but the application behind it is actually really simple, very common sense, and you use it without ever realizing you use it. And I'm going to show you what I mean by that. So the commutative property basically means that, and for addition that is, there's also one for multiplication, which we will get to in the next lesson. But you have two numbers, and they're equal to the two numbers if they switch orders. Still may be a little difficult to explain, so I'll show you an example. What's 6 plus 4? It's 10. What's 4 plus 6? It's 10. All it's saying is, when you take two numbers in addition, you can take 6 plus 4 or 4 plus 6, and they're both going to be the same answer. Now some students might say, do I really need to know that? Or do I ever really use that? And the answer is, yeah, you might actually use that, because if I ask you what 18 plus 2 is, you'll tell me that it's 20. If I ask you what 2 plus 18 is, you might switch it in your brain and say, oh, 2 plus 18 is 18 plus 2, it's 20. I know that's the way I think. If somebody asks me 13 plus 7, I can tell you it's 20. If somebody asks me 7 plus 13, I switch it really quickly in my head. It's like a millisecond, but I still switch it, and then I do it. And sometimes you're not cognizant of that. Sometimes you're not aware that you're doing that, but you are, and that's how your brain thinks. And somebody wrote this down as a property and said, you know, that's kind of how our brain thinks. And stated it, and I don't know if they got any fame or money for it, but they certainly got notoriety for it. Who did it? I have no idea, but somebody must have done it. The associative property works under the same pretense, and an example of it is best. It's much easier to show an example than to just try to explain the property, which is already in front of you, so you can stare at it and pause if you want to for quite a while and decipher it for yourself. But I'm going to go ahead and give you an example. I'm running out of room, so I'm going to use more. I have the numbers 1, 2, and 3, and I'm adding them. And according to what I have to do in addition, I have to do what's in the parentheses first. 2 plus 3. Well, 2 plus 3 is 5. And 5 plus 1 is 6. Well, instead of doing 1 plus 2 plus 3 and adding the 2 plus 3 first, you could add the 1 and the 2 first. 1 and 2 is 3, and then 3 plus 3 is 6. That's all it says. When you're adding more than two numbers together, when you're adding three numbers together, for instance, you can add the first two together, or you can add the second and third one together first, but as long as you do your addition correctly, the answer is still going to be the same. And I do that too. Example, 13, 7, and 20. Well, I would have trouble doing 7 plus 20 plus 13. I know 27, and 27 plus 13 is 40. But if you ask me 13 plus 7 plus 20, and I did 13 plus 7 first, 13 plus 7 is 20, 20 plus 20 is 20. And then again, that's how your mind thinks. You might not be aware of that, but that's actually what your mind's doing. And the more you practice it, the more you're aware of what's actually going on when you're doing the math, which is actually the subtle brilliance of it. And sometimes students don't like doing homework problems or homework in general. But I promise you, it's really like a muscle, and if you just want to, you know, be strong, but be strong here, then you got to practice what you're supposed to do. The next one I have is the identity property. And basically the identity property says, well, what can I add to something to make it exactly the same? That's not a trick question. If I have the number 7, what can I add to 7 so I make sure the answer is 7? And somebody came along and said, well, you know, if you add 0 to a number, the answer is going to stay the same. Let me give you a quick little peek of what I'm talking about. I'm going to add nothing to myself, and I'm still going to be the same person on the inside, but I might look different very quickly. I'm going to show you this little brief example. Here's Mr. Shahadi turning around. Whoa, where'd he go? The person that was on the camera had glasses. This person doesn't have glasses. Well, actually, I'm still the same person. It's an identity crisis. I decided to put my glasses on and taking it off. I'm still the same person. you know, I thought that joke was actually pretty funny, the identity crisis. You're trying to change something about yourself, but you're really the same person. Maybe I'm the only one who thought it was funny. I really do hope there was somebody else. I can't continue with that, never mind. The last one is the inverse property of addition. And basically what that states is, if you have a number 3, what do you add to it to cancel the 3 out? You know, to make it non-existent. Or if you have 5, what do you add to it to make it non-existent? And the answer is, it's inverse, it's opposite. And its opposite in this case is, well, I have 5. If I add negative 5 to it, goes away. Answer is 0. And that's a brief overview on the properties of addition. Pretty fascinating in their own right. Pretty fascinating in their own right. With that said, have a great day. Goodbye.